Mr. Kumar has over 22 years of engineering and management experience in cost estimating. There we go. In cost engineering, scheduling, risk analysis, and supervision in the federal government. He is currently the COP leader in the U.S. Army Corps of Engineers headquarters, Washington, D.C. In his current position, he is responsible for developing and maintaining cost engineering policy, development, and maintenance of training materials for over 430 cost engineers within the Cost COP, including prospect courses and webinars across the enterprise. He is a subject matter expert in cost engineering policy, estimating, scheduling, and risk analyses for MILCON and Civil Works for USACE and other federal agencies. He served as a cost engineering branch chief at USACE New York District, managing cost engineering program for approximately $500 million a year in both MILCON and Civil Works programs. He served as the district support team manager under the Civil Works Integration Division at USACE Regional Headquarters, North Atlantic Division. He provided voluntary support during several contingency operations for the Corps, including COVID-19 pandemic, where he led a team of cost engineers at the New York District in development of working estimates and independent government estimates for COVID acute and non-acute alternate care facilities within New York District area of responsibility. He holds an associate's degree in aeronautical engineering and technologies and a Bachelor of Science in mechanical engineering. He is a registered professional engineer in New York and a DoD Tri-Services certified cost engineer. So with that, I'll turn it over to Mr. Mukesh. Welcome, sir.
Hey, good afternoon, Stephanie. Thank you. Just audio check. Can you hear me?
Yes, sir. We've got you.
All right, perfect. So let me just share my screen here. Perfect. I'm hoping that's coming through.
Yes, sir. We see it.
All right. Good afternoon, everybody. Like Stephanie said, thank you, Stephanie, for that introduction. Mukesh Kumar, I'm the cost community practice leader with Headquarters USACE. Today, the topic is going to be cost engineering and cost estimating and cost control mechanisms in general. I know we are talking about probably sustainability at some point, but the objective today is to kind of walk through some of the processes that cost engineers undertake within the Corps, along with cost classification and some of the regs that we have to kind of comply with. Again, I'm going to skip this slide because Stephanie just kind of went through that. So here are some objectives for today's webinar. I'll probably speak for about 30 to 40 minutes, and then we'll open up for questions. During the webinar, I will not have ability to read the chat, so I'm assuming either Ed or Stephanie would kind of help me kind of gather those questions at the end of the webinar. So from the cost engineer cost estimating process, we'll understand the importance of scope, define cost classifications, contingencies, and risk management, and then we'll get into cost control. And we'll look at some historical data on some of the projects that we had either authorized or had been budgeted, but then over the years, kind of costs went up and we had tremendous cost growth, and we'll look at some of the factors what caused that. So right off the bat, cost engineering. So this is COSCOP's objective. And you can read the statement, but I really like to point out to the word adequate. So what does that mean when it comes to budgets, right? Well, when in MILCON arena, when we have a 1391, basically what we're saying is based on the scope that's defined in the 1391 and the amount that's authorized within the 1391, we will deliver the facility complete construction within this authorized amount, within this approved 1391, right? Civil Works, same thing. When a project is authorized through WRDA, it has a scope and it has a cost. And WRDA is a little bit different. I mean, civil works is a little bit different where we have a 902 limit and we also have inflation because funding for some of the civil works projects could take several decades before we finish construction on the project. So adequately programmed, authorized, and appropriated in all phases of the project. So that's the key. And we'll kind of, as we go through it, we'll see there are some challenges as far as making sure that this happens when we go through the budget process. So let's kick off with some of the factors that kind of affect the quality of a cost estimate, right? We'll get into some of the classifications, but really the important aspect is that as we get higher and higher in the cost class, we have about 5 cost classifications. Information becomes very limited and sparse, and therefore the risk with that particular class of cost estimate is high. Now, since Mr. Perez, who's the chief of PNC currently up at headquarters, since he came on board and he kind of asked cost engineers and cost engineering community and said, hey, every time we have a cost growth, we talk about the reasons and what he has been able to understand is that, okay, there are reasons that are beyond our control. And there are reasons that are in our control. And sometimes when we are briefing senior leaders, as far as what caused the cost growth, I want you to put it in 2 buckets, controllable versus uncontrollable, which kind of makes sense. Controllable is something that we can take care of from a management standpoint, from PDT standpoint. But uncontrollables, we got to also realize that there are going to be uncontrollables that no matter what we do, no matter how much engineering, design, scope, information we gather, there are going to be uncontrollables that are ultimately going to affect your overall cost estimate in the end. So some of the controllables, number one is the scope, right? And as you will see throughout my presentation, scope is the number one item that drives the quality of an estimate. If you can't give me a clear scope, I can't give you a definitive answer on the cost. Now, what happens is you have a scope when you are, let's say, at really preliminary stages of project inception. Let's say we want to build a barracks building and we say, where is it? Somewhere in Texas or somewhere in New York, let's say Fort Drum. We want to build a barracks building. And that's all we know. Maybe we know the size of the building. Maybe we know how many cadets we are going to house in that building and so on and so forth. And that's fine, right? And I'll give you an estimate. But what happens is that's going to be a class 5 estimate. As we go through the design, then we start talking about the details. Hey, what is it that you are going to have in that building? What kind of exterior is it going to be? So on and so forth, right? Your systems, your electrical, mechanical, your weather conditions. If it gets too cold up there, what kind of heating system we're going to have, and so on and so forth. And as we, go through these different classifications, the time and effort to prepare that estimate also changes, right? Because if you want a class 3 estimate versus a class 5 estimate, I'm going to need more time and more effort. So again, scope number one, and based on that scope, we will, we have to make sure that we have enough time and budget to prepare that particular estimate. So in other words, we don't want to make it quick and fast, so the quality is going to be really bad on that. We don't want to be too expensive and too delayed. It's going to be useless at that point because we needed that estimate at a certain time, but we didn't get it. So there's always that sweet spot that we're looking for. And then controllable direct costs, labor, material, equipment. That's what cost engineers do day in and day out. They are responsible for that. They need to make sure they have the most current labor rates, material, and equipment rates. But then also, you'll see that as we go through the life cycle of a project, we have some policy changes, we have some directives, we have some executive orders. For example, right now we're dealing with PLAs, we're dealing with Buy Green, we're dealing with EPA clauses. Some of these clauses and some of these executive orders, they were not in place. For example, if you had a project that was budgeted 2 years ago, 3 years ago, 4 years ago, whatever the case may be. And as we go through the life cycle, new orders and policy changes and ECs and ERs and those things come into play. And those are, again, we're calling it controllables because we know, right? We know that it's there. We need to consider that so that we can account for that in the estimate. Now, the tricky part is that as we go through the project lifecycle, project risk classifications change over time. And we'll talk about this when we talk about risk registers and how we do the cost and schedule risk analysis. And then, other item we all know is the reviews, the quality assurance review, DQC, ATRs, IEPR, so on and so forth. And when we go through those reviews, we know that some comments may actually add costs, some comments may actually, save money, and so on and so forth. Now, if we talk about uncontrollables, again, these are the items that we don't have any control over. We can account for them to a certain extent, but definitely not. Above normal inflation, right after pandemic, our inflation was around 15 to 20%. And on both Milcon and Civil Works projects, we are mandated to use the OMB inflation rates. And those rates are typically 2.5% to 3%. So anytime we had a project that we were trying to budget into the future, to the midpoint of construction, we were bound to use those inflation rates. In reality, we knew that's not true, right? If this year, let's say we are budgeting for 2 years into the future, and we are in 2021 when inflation was 15%, and you're budgeting for 2 years into the future, for example, fiscal year 23 projects, you were bound to use 2.5% inflation rate per year. And we knew that this 15% in 21 is not going to come down to 2.5% in 2 years, right? So we took some measures there, but again, anything that we were executing in 21 obviously didn't have that inflation built in, and therefore we saw many projects that had bid busts and the bids came in really, really high. Supply chain disruptions. There's no way that we can forecast that into the future. We can assume what it is right now. We just don't know that. And that, again, that happened after pandemic. Labor shortages, material shortages, and so on and so forth. You can read the list, right? So these are certain things that we can account for, but we can never account for in its entirety. So let's get into cost classifications. Again, the maturity level of project definition is the sole determining factor. Now, the table on the right that you see is from AACEI 56R08. AACEI is the for Advancement of Cost Engineering International, Association for the Advancement of Cost Engineering International. And 56R08 is their publication, which is an industry standard for cost estimate classification system. So they go from class 1 to class 5, like I said earlier. Class 1 is basically, in usage terminology, that's your independent government estimate. That's the estimate that we take for requests for proposals, for invitation for bids, and so on and so forth. And then class 5 is when a project manager would really come to a cost engineer and say, hey, look, there's a need for a barracks building at Fort Drum. How much do you think I should budget for it, or how much do you think it will be, so that the base can start requesting funding and see if it's feasible, that level of estimate. And the table kind of gets into the design maturity and end usage methodology, how the cost estimates are prepared, and then accuracy range, which is your contingencies when you do cost and schedule risk analysis. Now, I want you to read bullet 3 there, which is important, and it's really a spinner as well. And I'll try to explain it without confusing everybody. So the plus or minus value represents typical percentage variation at an 80% confidence level interval of actual costs from the cost estimate after application. Now, in parentheses, it says typically achieve a 50% probability. Okay, so your 80% confidence level is at your risk neutral estimate. What does that mean? That means when we do cost and schedule risk analysis for a Milcon project, typically we choose risk neutral estimate, which is that the 50% probability of that particular estimate. So the ranges that you see on your right is at the 80% confidence level, which means they're saying 80% confidence level at 50% probability. Okay, so it is a little confusing, but what it's saying is, so a 50% probability is a coin flip. When we budget an estimate, let's say we're preparing a 1391 and my PA is, including contingency, is $5 million. What we are saying is there's a 50% chance that we can deliver that program with $5 million. There's a 50% chance that we will have bids that will come in high. The 80% confidence level is saying that we are 80% confident that 50% of the time we can deliver that project, if that makes sense. So that's really what it means. In other words, there's huge uncertainty with these percentages. Now, the next statement, for complex or otherwise risky projects, the high ranges may be 2 or 3 times the high range indicated, right? So that's even another uncertainty on top of that. So in other words, what they're saying is, hey, make sure that you get your scope right. Make sure that your main features are defined to the level that you can get to a place where you have more confidence in the scope, and then you can reduce your uncertainty, because you can see that as the class goes from 5 to 1, that range kind of narrows down. Like, for example, class 1 is 3% to 10%, obviously, because you have almost 100% of the scope defined at that time. Now, this is also true for any sustainable materials or any new items that we introduce in the project. Right now, if you are coming in, or if the administration wants us to look at sustainable materials, we need to make sure that we define those materials. We have the specs in place. We need to make sure the tolerance levels for any materials that we are speccing out is clearly defined, so that we can prepare the estimate for that particular item in the sustainable arena. So here are some of the next few slides are just kind of going into what are classified, what different cost classifications and what they entail. Again, class 5 estimate project definition is 0 to 2%. Again, it's prepared with very limited information. We're just kind of verbally talking. There are no plans, there are no sketches. You may not even have the site picked out where the project is going to go, and so on and so forth. Again, this estimate can be prepared on the fly. You could be just at cost engineer's cubicle, talking and saying, hey, this is what I want, and cost engineer will really look at, again, quickly historical data and say, yeah, maybe, I don't know, $50 million. And that's it. That's your class 5 estimate. Class 4 estimate, again, you may have some more defined scope. Maybe you'll say, hey, it's going to be at Fort Drum, and it's going to be at that XYZ site. This way, you at least know, okay, you have your utilities in place. You will know where you're going to tap into the utilities. What kind of site you're dealing with. Are you going to do any clearing and grubbing? Are there any buildings on site? Do you have to demolish them? Again, no drawings. It's basically, maybe you have a Google, picture of the site, and you can prepare a class 4 estimate based on that. Again, it will be probably a little bit more detailed than a class 5 estimate. This could get into like an Excel sheet type estimate, and so on and so forth. Class 3 is where we start getting into some of the details, like you'll have a site plan, you'll have some of the features defined, you may have some, let's say if you're talking about buildings, You will have some typical elevations, maybe cross sections, maybe some of the architectural features are defined. You may have your HVAC, heating and cooling loads identified, maybe systems identified, but nothing really on the drawing. You may have line diagrams and so on and so forth. And the way this estimate is prepared, it's now we're getting into the cost engineering tools, right? We got MKC software, we got PACES, we got, you know, some of these quantity takeoff softwares, like if you have plans, we can do some quantity takeoff with that electronically. Probably not BIM yet, but um, it is more involved. In other words, the estimate is prepared we call it BOP approach, where you're actually creating crews and assemblies and you're defining features, you're defining your work breakdown structures, substructure, superstructure, roofing, exterior closure, HVAC, plumbing, mechanical, electrical, and all that. And this is going to be more involved. It's not going to be just one-on-one discussions with project manager or technical lead or so on and so forth. But cost engineers are probably going to be talking to each lead, technical lead, structural lead, mechanical lead, electrical lead. They'll be talking to civil engineers and so on and so forth to kind of get info on the missing pieces that are maybe not on the drawings, that are not defined yet, and they are kind of getting enough information to kind of build up their estimates so that they can have assumptions on some of the areas where we don't have any clear information. There are I would say in a class 3 estimate, you will see usage of lump sum items to a certain degree. For example, if you're doing a LEED certified building, you may see a 2% fee for that. If there is building information systems or whatever the case may be, not defined yet, you may see a lump sum item. So some of these systems that are not well defined yet, the cost engineers may use lump sum items based on historical data, similar projects, similar location, so on and so forth. So again, as you can imagine, it will require more time and effort on cost engineers' part. So therefore, it'll take more time and more money to do this type of estimate. One thing, class 3 estimate is now required on all MILCON, Army MILCON projects during the Code 2 process. Basically, your design is around 35%, which kind of falls into the 10% to 40% project definition range. This is also required for civil works projects, where when you are recommending a NED plan, the chief's report, you got to have a class 3 estimate going forward. So budgets are set with a class 3 estimate, nothing less than that, not a class 4, not a class 5. A class 2 estimate is again a little bit more design, the definition. You now have plans and specifications not fully developed, but almost there. I would say pre-final if you're at 70% phase. Again, this is where you're still doing bottom-up estimate, and now you're probably close to your final estimate. Your lump sum items are going to be reduced to a larger degree, to minimum, and you are kind of very close to your class 1 estimate at this stage. And again, your class 1 estimate is now your IGE. You have all your plans and specs. You know your site. You have gotten the quotes from vendors on large ticket items as a cost engineer. Your specs are fully defined. We have location identified. We know the long lead items and so on and so forth. And we are ready to go for advertisement. Now, the effort, depending on the size and scale, it could take several weeks to months preparing this estimate. But I'll still say that class 2 is probably where cost engineers and the PDT will spend most of their time. And at IGE phase, you probably have your skeleton built, your assemblies, your crews, and all that, and then you're basically just refining your IGE after that. Now, after everything is said and done, we still got to identify risks, right? And again, as we go through the life cycle of a project and we go through different classifications of your cost products as you go through the design, your risk changes, your risk may be mitigated, new risk items come up, and we need to make sure that we identify those because that is part of your contingency, that is part of your total project cost. So when you are on at a stage, for example, class 5 estimate, class 4 estimate, I would say your lessons learned is probably where you want to be relying on to kind of identify risks on similar structures, what went wrong, if you had a bid opening in the area on a similar structure. You can use those examples and lessons learned and kind of include that in the baseline estimate. Anything that's still uncertain, you can throw that in your risk register. But I do want to highlight that cost and schedule risk analysis will not reduce uncertainties due to lack of investigation or design maturity. For example, let's say we don't have the site picked up and we are trying to come up with a contingency and we say, hey, you know, similar structure we build. This is what happened, and I think we were around XYZ for site work. Let's say, I don't know, a couple of $1 million. Now, okay, you could use that, but you know, you go through your design maturity and you have a site picked, and all of a sudden the site that we picked either has large quantities of rock that requires blasting and excavation, or it has some HTRW on site that will require remediation, so on and so forth. So what I'm saying here is that the historical project or lessons learned that you use may not have those two items. And I can tell you this, working with New York District, whenever we had a project at West Point, we could spend millions and millions of dollars and months to just clear the site in order to get started with preparing the site to build the project. We had a barracks building, Davis Barracks, where we spent upwards of $30 million just clearing the site. Nothing else. We were just blasting the rock, leveling the site so that we could start building the building itself. So again, so your site investigation, design maturity will not replace your cost and schedule risk analysis. Contingencies are not a means of offsetting unknown scope, right? Again, kind of ties into your second bullet that we can say, oh, yeah, well, we don't know enough, but let's just put that in the contingency. You could add 10%, 20% contingency, but the cost may actually come even higher than what that 20% would translate to once we have identified the scope. Put bluntly, no amount of contingency can mitigate an undefined baseline or undefined scope. Partnering with our customer stakeholders through honest risk identification. What we are saying is anybody who knows about the project, maybe there's a base, we have BPW, if it's a Civil Works project, non-federal sponsor, anybody who can add value to the discussions during the cost and schedule risk analysis about the project, about the site location, we should be talking to them and kind of mitigating all those risks that we know that will be realized or has the potential to be realized. We should account that in the baseline estimate. We should never throw that in the risk register. Any variations to the baseline estimate is where the risk register comes in, and then you're running your models based on those variations, and you're modeling those variations. Okay, so cost control measures. So we have prepared the estimate, and we have done the cost and schedule risk analysis. How do we track? How do we make sure that now that we have established the budget based on the scope, that we kind of don't go over what we have budgeted for? Well, we need to make sure that we need to update those cost estimates every time we have a design update or we have a major change. Again, have a PDT meeting. If it's a milk run project, obviously we do 35%, 60%, 90%. But if it is a complex project, if there are several moving parts, I would even recommend doing it, at a 30%, 50%, 65%, 90%, so on and so forth, depending on your schedule and resources that you have. And then again, who is developing the cost estimate? What is your technical team? How experienced is the PDT? And then your independent quality assurance of cost products, right? So make sure that your scope and your cost products, they are kind of reviewed by third party, because I'll tell you that there are several instances where optimistic bias kind of creeps in, and we have a number in mind just because we have a budget, we have a 1391, and we try to kind of make sure that we don't exceed that number knowingly, unknowingly, whatever the case may be. And then we say, let the market decide, and we'll then figure it out. And then we have an ATR at our hand and a bid opening. Managing expectations, again, we need to make sure that whenever we have a update to the cost estimate, anything that has changed in the baseline, in the scope, in the risk identification, if we have actually used up the contingencies of the project, we need to make sure that we are tracking that as well and inform the project manager, the PDT, senior leaders, that, hey, we had a 20% contingency, but we are at 35% or 60% design, and we have used up about 19% of the contingency. So right there, I think the PDT should really start looking at some of the mitigation on the scope itself, or some of the thought process should be, how can we keep the project under control so that when we are at 100% scope IGE level, that we don't have any surprises on the bid opening day. Cost control measures, again, continued. As you can see in this chart, probably familiar with this, the cost of changes are minimum when you are really at the beginning of the project. And as you go through your life cycle of the project and design, the cost of those changes are extremely high. I'll give you an example. We had a civil works project where the team went to 100% plans and specs and did not update their H&H models. And for some reason, when they updated it, they realized that they are inducing damages to the existing structures if they build the project the way it is, identified within 100% plans and specs. And they had to basically go back to the drawing board because they didn't use the right modeling. They used 1D versus 2D versus 3D modeling, and they didn't use the right historical event on that particular project. So that cost huge amount of money, time. Obviously, non-federal sponsor wasn't happy. The congressional delegation wasn't happy, and nobody was happy. So we need to make sure that we are in a collaborative phase all the way through the project, kind of going back to the objective of cost engineering, right? It's adequately programmed and managed throughout the life cycle of the project. The one thing that I don't see, and I really would like to see, that when you have a risk register and prepared during cost schedule risk analysis, or if the project itself has a risk register, somebody should be owner of each register, each risk in that risk register, which means that somebody should be tracking it, somebody should be following up on it, somebody should be mitigating it. And once that's done, there should be discussion where they can then come back and say, okay, we no longer have this risk, take it out. You may actually lower your contingency, right? Or, hey, new one just popped up, maybe whatever it is, and you add that in there. And I guess, in other words, what I'm saying is your risk register is a living document, just like your PMP. Somebody needs to be managing it. Somebody needs to be, just like your scope. You may not have enough scope in the beginning of the project, but as you have gone through it, that may actually lower your contingency, but may increase your baseline estimate. Risk management involves revisiting risks and contingencies development multiple times throughout the project lifecycle. So when scope translate to dollars, so this is where I like to highlight the difference between the scope maturity and design maturity. This has been really a topic of discussion on the civil works side of the house. So in other words, how can you define um, the scope of a project when you are really at your preliminary phases? And the question that I constantly get is, we can't possibly define, have 100% design in order to make sure that we won't have a cost growth, right? So my answer is that's true. So the difference between scope and design. So scope is your definition of the project. In other words, my definition of barracks building is it's a 25,000 square foot building with brick exterior. It'll have a cooling a tower, uh, heating and cooling. It'll have, I don't know, electrical load that will be defined, what kind of lights there are, what kind of finishes we're talking about. To me, that's scope. And as a cost engineer, I can prepare the estimate based on the scope. Design maturity is the steps that you take as a designer to define that scope. In other words, what load calculations somebody has to run, electrical or mechanical engineer, to say, I need a 50-ton unit or I need a 60-ton unit, right? So that's the design maturity. Now, design maturity also, some architects or engineers will define it as number of plan sheets. Say, hey, I need to have X number of typical cross section and X number of plan sheets so that I can get at a 35% design. To me, okay, if that's your definition, that's great. But if you tell me that I have a brick construction, a 25,000 square foot building, it has 4 floors and a basement, I'm good with it. I can go with it. I can run with it. I have enough historical data and I can give you an estimate. I can probably give you a class 3 estimate unless you change the size of the building. Now from 25,000, now it becomes a 35,000 square foot building. And oh, by the way, the load, the cooling and the heating load, it doubled. Or you're putting it in a location that now requires additional, treatment to the site. Maybe there's a rock on site. Maybe there's HDRW on site, right? So, so again, your scope changed, but I don't need your, design to be to the level where I have, 100 sheets and I got to go through each sheet to kind of get my estimate. So to me, that's the difference. So Pareto principle to the scope, probably not. You got to give me your full definition of the scope, what you're trying to do. On design, yes, there may be some aspects of the project that you need those drawings. For example, your site, I need probably well, developed site plans in order for me to make sure that I'm considering, where the utility tap-ins happens, where the parking lot is going to be, and so on and so forth. But some of the typical cross sections, I don't need that. Maybe the construction folks need, how to build, how to construct, and so on and so forth. Um, Here are some of the reasons. So we looked at several projects. Again, I'm sorry, this is Civil Works, just to be transparent there. This is from the Civil Works side of the house. We've been busting numbers and costs been going up and up on the authorized project. And Congress said, hey, you say score, tell us what's happening, what's going on. So MCX did analysis on what's causing cost growth on some of these projects. And again, as expected, your number one was the definition and packaging of the product, clear scope of work. Definition and packaging of the product is really, when it comes to acquisition strategy and how many construction contracts you're going to have. Again, Milcon doesn't have that issue. But really, Civil Works side, you could say in feasibility phase that, hey, I'm going to build this project with 2 construction contracts. And then actually, when you start getting funding in drips, you end up chopping that project into maybe 20, 30 different contracts, right? So that kind of adds up to the cost. clear scope of work. We have actually seen that in Milcon Code 2 process as well, how the project cost is actually grows from a programming level, DPW level estimate all the way to the bid opening and how the scope changed and all that. Accurate contingency levels on civil works sites. We started using cost and schedule risk analysis back in 2000, I would say 7 onwards. But in Milcon, I think it was in 2021 or 2020, we started using cost and schedule risk analysis. And we're still really in initial learning phases on the Milcon side, where what I'm seeing is when we review those Core 2 packages, the contingencies are kind of lining up at 15 to 20% level, no matter what the project is, no matter how complex the project is, no matter how big, small the project is. So maybe there is also some learning curve there that we need to kind of understand what's going on there. Again, define acquisition strategy. We always budget for IFP, and then we end up being at the mercy of contracting officer, where they're like, oh, well, we got to do 8A negotiator, right? So add 10% to that. That's not included in your budget, by the way. Or we need small business restricted, and whatever the case may be, right? So again, top reasons, this is kind of going into further details. Scope changes, design changes, as you can see, is the highest bar there. And then you have others, policy, funding, risk analysis, and so on and so forth. So again, scope is the key here, no matter what you're doing when you're asking for a cost estimate. And the process really for cost engineers is to understand that scope and then either build a bottom-up estimate or look at historical data and use several tools at our disposal that you may use to kind of build those cost estimates. And then again, class depends on your design maturity and so on and so forth. That's all I had today. I think it's about 40 minutes, like I said, but I'll open the floor for any questions that you may have.
So we don't have anything in the chat, so if you have a question, just unmute and have at it. Well, that's it, Mukesh. You did such a good job that nobody has any questions. Thank you for your time. I really appreciate it. And to everybody, we'll have the slides and also the video as soon as it generates. I'll have that at the link at the very top of the chat. So it'll be the same place as always. We do have upcoming on July 25th. We have a presentation, kind of a pop-up presentation. It's not on schedule with or in series with the Tuesdays. It's going to be on a Thursday, but we have Ryan Murphy's going to talk to us about AI. So please, I anticipate lots of questions and interaction. So there'll be a separate invitation coming out shortly. So be aware for that. Mr. Kumar, thank you so much. I very much appreciate your time. It was a great presentation, very thorough. Thank you so much.
Yep, no problem. You're welcome. Thank you.
All right.
Bye, everybody.
All right. Bye, everybody.
Bye.